All right, we looked at the first derivative test to find the relative max and mins of a function. And for that first derivative test, we said, okay, what do? We basically find out where I have a derivative that's 0 and check on both sides to see where it's positive, negative, okay? All right, for the second derivative test, here's what this says. Suppose that f is twice differentiable at the point x naught. If f prime of x naught is equal to 0, well, what does that mean, first of all? That means the values of x where your first derivative is 0. So you find the zeros of your first derivative. And at that 0, your first derivative, if you evaluate your second derivative at it, and it's positive, then f has a relative minimum at x naught. Think about this for a second, okay? Suppose I have this curve right here. My first derivative is 0, right? So it'd be like that x naught value they're talking about. And then it says, what if you take that x naught value and you sub it into the second derivative function and it's greater than 0, or it's positive? Well, that means that your concavity, if your second derivative is positive, your concavity is up. So that makes a minimal. What about this one? What if you find where your first derivative is equal to 0 and your second derivative is negative? If your second derivative is negative, that's like your concavity going down, right? And where your first derivative is 0 at that x naught value, then you have a relative max. All right, but what if you find your zeros of your first derivative and you evaluate your second derivative there and it's equal to 0, so neither positive nor negative? Then the test is inconclusive. You may have a relative max, relative min, or neither at x naught. So you have to go back to the first derivative to find out for sure. So why would you even use the second derivative test? Well, let's say that you're playing the stock market, okay? And you want to know where you have low points and where you have high points on it, and you're writing a program to find that. It'd probably be a lot easier to write a program that uses a second derivative test to find a bunch of them than it would for the first derivative test. All right, anyway, let's use this second derivative test, okay? And if you look at the example in your notes, it tells me to use the second derivative test to determine the x values of any relative max or mins. And they give me f of x is equal to 3x to the fifth minus 5x cubed plus 3. And they want me to use the second derivative test to find the max and the mins. All right, so what do I do to use the second derivative test? Find the zeros of the first derivative. So my first derivative will be 15x to the fourth minus 15x squared. Well, let's factor this. I can take a 15x squared out, and I'm left with x squared minus 1. That's my first derivative. So let's find the zeros of this first derivative. So we're going to take this first derivative, set it equal to 0. Now I'll take each one of these factors and set them equal to 0. 15x squared is equal to 0. X squared minus 1 is equal to 0. So that means x squared 0. If I divide by 15, so x is equal to 0. Over here I get x squared is equal to 1, so x is equal to plus or minus 1. All right, now what did the second derivative test tell me to do? It told me take my second derivative and evaluate it at each one of these points right here. So what is my second derivative? Well, I'm going to take the derivative of this instead of that one because I will not have to use a product rule here. So what does that give me? That gives me what? 60x cubed minus 30x to the first, right? Now let's evaluate the second derivative. Actually, let me put 2 right there because it's second derivative. Let me evaluate the second derivative at, say, positive 1. At x is equal to 1. So I'm going to take the second derivative, evaluate it at 1. So that'll be 60 times 1 cubed minus 30 times 1 if I substitute it in for each x. What does that give me? 30? So that's a positive, right? That's greater than 0. So what do I know if my first derivative is equal to 0, which is at 1, and my second derivative at that value is a positive? Then I know I have a relative minimum at x is equal to 1. All right, let's test negative 1 at x is equal to negative 1. Let's evaluate my second derivative at negative 1. F double prime of negative 1 is equal to 60 times negative 1 cubed, 60 times negative 1 cubed minus 30 times negative 1. What does that give me? Negative 60 plus 30 says negative 30, which is less than 0. So what happens if my second derivative at that point is less than 0 or negative? Then I have a relative what? Max. Relative max at x is equal to negative 1. Now what's left? I checked positive and negative 1. I still need to check what? 0. How about it? X is equal to 0. And x is equal to 0. Let's evaluate my second derivative at 0. So f double prime at 0 is equal to 60 times 0 cubed minus 30 times 0. That gives me 0. So what can I say about it 0? The test is inconclusive, right? So I need to use something else then to test 0. How about my first derivative test? Let me use my first derivative test then at 0. So what I do for my first derivative test, I drew a number line, and I called that number line f prime, right? And I put these numbers on at my critical points, which were 0, negative 1, and 1, right? All right, so what do I need to do now? I need to test here and here to see what happens on each side of 0. So let's pick a test value here like negative 1/2 and run it through my first derivative. If I run negative 1/2 through my first derivative of negative 1/2 squared, which is a positive, times 15 is a positive, negative 1/2 squared gives me a positive 1/4, minus 1 gives me a negative. And what's a positive times a negative? A negative there, right? How about a test value over here, like 1/2? Let's run that through my first derivative. And I'll get a positive here. How about here? What will I get? Negative? What's a positive times a negative? A negative, right? So what does that say in f does here? It decreases and decreases. So if it decreases and decreases, I don't get a maximum nor a minimum there, right? So at x is equal to 0, neither max nor min here. All right, so what were the instructions to this problem? Determine the x values of the relative max and relative min. Relative min at x is equal to 1, we said. Relative min at x is equal to 1. And relative max at x is equal to negative 1. Now notice, they don't actually ask what is that max. If they did, if they asked what is that max, I'd take negative 1 and plug it into my original function, okay? And that y value will be my actual max. All they want is the x values here though. All right, let's take a look at this last example. And it reads, use any method to find the relative extrema. Use any method to find the x values of any extrema. So we're only looking for the x values of the extrema here. And we have f of x is equal to 18x to the 7/3 minus 9x to the 2/3. All right, so it's up to me now if they say use any method. So I'm going to use a first derivative test. I'm going to say f prime of x is equal to, let's multiply 7/3 times 18. Well, 18 divided by 3 is what? 6. 6 times 7 is 42. X, and take away 3/3 from this, and what are you left with? 4/3. Minus, I could say that this is what? 6x to the negative 1/3, right? All right, usually what we do is we factor here. Let's factor out a 6x to the negative 1/3 out of this. And what are we left with? 7x to the what? 5/3? Think about that. What's negative 1/3 plus 5/3? 4/3, which is what I want, minus 1. Well, I could do a rewrite and say this is 6 over x to the 1/3 times 7x to the 5/3 minus 1, and that's f prime of x. Now, let's find the critical points. So let's find out where f prime is equal to 0, and let's find out where it's undefined. Well, let's set it equal to 0. 6 over x to the 1/3 times 7x to the 5/3 minus 1. Let's find out where it's equal to 0. And where is it going to be undefined? Well, my denominator, x to the 1/3, is 0, or my denominator is 0. All right, take each factor here, set it equal to 0. 6 over x to the 1/3 is equal to 0. 7x to the 5/3 minus 1 is equal to 0. So if we try to multiply both sides by the LCD, we get 6 is equal to 0, which is not useful to us. Over here, when I solve, we get x to the 5/3 is equal to 1/7. And then I take the, raise both sides to the 3/5 exponent. So x is equal to 1/7 to the 3/5. That's ugly, huh? I guess we could clean that up a little bit. Let's just go ahead and call this x is equal to the 5th root of 1/7. Let's do it this way. Of 1/7 cubed. It really doesn't matter, okay? I'll tell you what, let's just do this for simplicity. All right, let's raise both the top and the bottom to the 3/5, okay? What's 1 to the 3/5? 1. 7 to the 3/5, I just write as 7 to the 3/5. Make sure I'm still in a shot here. Yeah. What happens if I cube both sides here? I get x is equal to what again? 0. So if I'm using a first derivative test, I'm going to call this number line f prime. I'm going to break it up with 0 and with 1 over 7 to the 3/5. Okay, I know it's positive, so I'm going to put it over there. Now, the problem is, whenever I try to run test values, this is not going to be a problem, but here will. Like, what is this number about? Okay, so I can accurately use test values in there. So just take your calculator, compute that, and you get something like 0.311 for that. All right, so let's see. Let's run some test values here, here, and here, okay? Let me give myself some more room here. All right, let's take a test value of -1, okay? Let's run it through here. The cube root of -1 is -1. -1 to the first is -1. 6 divided by -1 is -6, right? How about -1 here? Cube root of -1 is -1. -1 to the fifth is -1. Times 7 is a -7. -7 minus 1 is -8. And a negative times a negative will give me a positive here. How about right here? Let me use a number between 0 and 0.31. I don't know, maybe a fourth? A fourth. So plug in a fourth here and here, and just put it in your calculator, okay? That's the easiest way to do that. If you do that, you get negative here. Then if you pick a number greater than 0.311, you get something like a positive right here, okay? So what is F doing? F is increasing here, decreasing there, and increasing there. So what are they wanting here? They're wanting to find where the max and mins occur. So what happens here if your function F is going from increasing and decreasing? You're going to have a max, relative max at x is equal to 0. And what happens right here if your function F is going from decreasing to increasing? It's going to have a relative what? Min at x is equal to that nasty number, 1 over 7 to the 3/5. Now, there's a number of ways you could write that. You could write that as 1 over the 5th root of 7 cubed and so forth, okay? All right, just use that first derivative test.